Okay, let's go over homework 4.3, number 8, part B. Alright, so part B, we're looking for local maximum and local minimum. So let's take the first derivative. So f prime of x is equal to, alright, so whenever you take the log of something, you're going to have to put whatever inside the logs on the bottom. So x to the fourth plus 27. Take the derivative of that, you get the 4x cubed. Right? So we set that equal to 0 so that we can find the critical number. But you can see that we just have to set the numerator equal to 0. So 4x cubed must be equal to 0. But we can just divide through by 4. Then take the cube root of both sides. So you end up with just x equals 0, right? So there's only one critical number in this case. And the denominator is never 0, so this rational function is always defined. So f prime is always defined. All right, then let's do a number line so that we can get the idea of what the graph is going to look like. All right, so you can see that here, so this is a critical number, it's 0. Then we're looking at this sign of the first derivative, right? So we plug in something smaller than 0, so I'll try -1. How about that? All right, so if you plug in -1, you can see that the numerator is going to be negative because a negative cube is still negative. But the denominator is actually always positive because 4th power plus 27, so it's always positive there. So we can see that the derivative at -1 is actually negative. So we'll put the negative sign there. All right, let's try something bigger than 0. So f prime of 1, right? Well, you can see that the 1 cubed times 4 is positive. And as I said before, denominator is always positive. So it's positive. So you have a positive sign here. All right. So the first derivative indicates that the original function f is gonna decrease before 0, and after that increase after 0, which indicates that you're gonna have a local minimum there. So a local minimum at x equals 0. All right, so we found local minimum. So local min is local minimum is going to be f of 0. So f of 0. All right, plug in 0 into the original function. So natural log of 0 to the 4th is 0 plus 27. So it's simply natural log of 27. All right, so we have that. So that's the local minimum. But you can see that there is no local maximum. So because there's no other critical number, so you have a local maximum would be does not exist. So D and E is the answer. All right. So now we can talk about the second derivative so that we can find the inflection points. So I'll take another derivative. So you take f double prime of x, right? All right, we're going to have to use a quotient rule here. So let's take the quotient rule, right? Square the bottom. This gets kind of confusing, so I'll erase those, right? Square the bottom. So quantity x to the 4th plus 27 squared, all right? Then derivative of the top is going to be 12x cubed. All right, and then actually 12x squared. and you have x to the fourth plus 27 minus 4x cubed times derivative of that is actually 4x cubed. All right, then we need to simplify a little bit. So let's see. What we can do is just factor out common factors. Looks like we can pull out 4 differently. 4. And also x squared. That might be the best we can. So x squared. All right. So if you pull out x squared, and 12 is 4 times 3, so maybe I'll write that here, 4 times 3, right? So we'll pull out 4, right? So what's left is 3 times x to the fourth, so it's a 3x to the fourth power, plus 27 times 3, so 3 times 7 is 21, 21, and 3 times 2 is 6, so 6 plus 2 is 8, so it's 81, right? And then we pulled out, let's see, 4, and also x squared, so there's going to be, I'll just erase that, so you have another x there. So it's going to be minus 4, so minus sign took care of that, and there's going to be 4. Then you have x to the fourth. All right. Then you have, so we took everyone, and the denominator stays the same. So quantity x to the fourth plus 27 to the square. All right. So we can just simplify that a little bit further. We can say 4x squared is there. And then you have 81 minus x to the fourth, right? So then you have x to the fourth plus 27 squared. All right, so, and then we set this equal to 0, right? So we can find x coordinate of possible inflection points. All right, so let's see. So definitely from here, x equals 0 would make the whole thing equal to 0. So I'll do x equals 0, right? Then from here, all right, so it's going to be 4th root of 81, which would be 3. And since it's a even power, so it's a plus or minus 3. All right. So we have to do a number line just to make sure that there's going to be a concavity change, so that we know that we have inflection points. All right, so possible location is 0. All right, also -3 and positive 3. All right, so let's look at the sign of the second derivative. Right, so we can probably plug in something less than -3, so f double prime of about -4. All right, so if you plug in -4 here, so that's going to be negative, right? Then positive, and everything else is positive, so this is going to be negative here. All right, so you have a negative sign. And we can plug in something between -3 and 0, so we try -1. All right, so you have 81 minus -1 to the fourth. That's going to be positive, positive, positive. Everyone's positive. So you have a positive sign here. All right, and between 0 and 3, so I'll try 1. So f double prime of 1 is going to be 81 minus 1 to the fourth is going to be positive. Everyone else is positive. So it's actually still positive. All right, so then we plug in something bigger than 3. So I'll plug in 4. So you see that 81 minus 4 to the 4th is going to be negative. Everyone else is positive, so it's going to be negative there. So you have a negative sign. All right, so you can see that the concavity change actually happens only at -3 and also a +3. Right, so this is inflection point there, and there will be an inflection point there as well. All right, so let's find inflection point. So we need to plug in -3 into the original function. So f of -3 would be, all right, so plug in -3 in there. So -3 to the 4th is 81. So natural log of 81 plus 27, so 108. All right, is the function value at -3. And then if you plug in +3, it actually doesn't make any difference because it's raised to the 4th power since it's even power, so negative sign doesn't really make any difference. So it's going to be a natural log of 108. All right, so therefore inflection points that we are looking for would be, all right, first one is -3 comma natural log of 108. And the other one is +3 comma natural log of 108. Right? That's it. Those are the inflection points. All right. I hope that this was clear.